Hi and welcome back to our next element in our 73 element challenge during the lockdown. Hope you're keeping safe and sound. Just as a recap, we're going down the alkali group. Lithium, sodium, potassium, rubidium, cesium and francium, they all have similar chemical properties. Soft, silvery sort of metals that will be they burst into flames if they hit water. Very reactive, and they get more reactive as they go down the group. So have a look at cesium. Let's have a look at the atom first. Actually, 55, atomic number 55. So it's getting really busy. There is a lot of stuff going on here. We've got 55 protons and neutrons in the center, 55 electrons whizzing around the outside, and as you can see, once again, it's got that one single electron in its outer shell. And they don't like that. They either like it to be full, that outer shell, or have nothing in at all. Having one really irritates it. So that's what makes it very reactive. So atomic number 55, which makes it very heavy. It's in the same group here as lead, for example. Here's lead. Everyone knows the expression as heavy as lead. Now, if you pull up the card, you can see, first of all, he's big on the card. So you can, if you can remember that, you can remember that he's heavy. And he's melting as well. The melting point gets lower and lower as you go down the groups. If you look at our highest melting point metal is tungsten. Tungsten melts at 3,422 degrees centigrade. Whereas cesium is just about 28 degrees. It will melt in your hand if you hold it in your hand. Do not hold it in your hand. It will burn. It will blow your hand off. It's usually transported in ampules, which are like glass tubes, usually with gas of argon gas filling up the empty space, because argon is very calm. Now, he's slight goldy in colour. Cesium does have a colour. It's like gold. Looks like sort of liquid gold if it melts. It's fantastic stuff. Please, there's loads of cool stuff on YouTube showing this stuff being thrown into water. Stand well back. Right, if you have a look at the card here, you'll see these digits along the front. Now, this is an atomic clock. Now, cesium's claim to fame is in 1967, year I was born, cesium was used to define the length of a second. And how is that done? We used to use this kind of clock. Now, these kind of clocks have a pendulum. Now, they swing backwards and forwards. That would define your second. Not accurate enough. So then they moved on to quartz. Much more accurate. But if you want really accurate timekeeping, you have to use an atomic clock. Why do we need accurate timekeeping? It's mainly for computers, particularly our GPS, our global positioning system, needs super accurate time. And the particles in cesium will oscillate. So instead of a pendulum or a quartz, we've got cesium oscillating. And it's that accurate that if you used an atomic clock, you'd lose about 1 second in about 138 million years. So super accurate and defined the length of our second. Right, now in the last video, I mentioned that you were time travelers. What on earth does that mean? Well, Einstein had a theory, E equals m squared. Forget about all that. It's a fact that if you go faster, time slows down. If you get closer to the Earth's gravity, i.e. you're at sea level rather than in a mountain, up a mountain or in a plane, time slows down. So you are actually a time traveller. Now it's only a nanosecond, it's tiny, it's minute, and it's a good job too. Just ask Marty McFly from Back to the Future. So, sorry, yeah, now, so it's a good idea that you don't go travelling backwards and forwards in time. Now, you can see that you are yourself becoming a bit of a superhero. You've got some powers now. You are a time traveller. You're mainly made of the same stuff which creates stars and suns. You contain sodium in your body, so you have the well, sodium has the ability to slow down the speed of light to 38 miles an hour. So you've got some superpowers. So start going out and doing some super stuff. Thanks for looking in at our next element. Tomorrow is francium. And don't forget that if you want the high definition artwork of this emailed to you, just go on to elementscarpa.com and I'll ping it to you. All right, see you next time for francium. Thank you. Bye.